Okay, it says solve for x. They're not indicating x is a real number, so I said they could be complex. All right, you're given an equation, and a couple things you could do with it. You could certainly expand it out and multiply both sides by the LCD. Blah blah blah. It's really not a bad technique to do, but I will say it takes a lot of algebra. So I'm going to do the whiteboard. Oh, before I do that, though, I want to point out I've seen this question on the internet, and I would recommend you look at this guy solve it. Again, I always say look at other people do things, and you decide what you want to do. All right? I'm going to go to the whiteboard. Could open up the whiteboard over here. And, whoops, sorry about that. And let me write down the question. All right, the question, it doesn't look that bad, but I'll write this over here. X plus 7, X plus 8, X plus 9, X plus 10, over X minus 7, remarkably similar, right? X minus 8, X minus 9, and X minus 10. Now, I certainly know there's some answers that are not going to work, and some might be obvious to you at this point, but I'm not too interested in what's obvious and what's not obvious. One thing that I would say most people would do is they would simply just clear the fraction. And then you get X minus 7, X minus 8, X minus 9, X minus 10. Nothing wrong with that. Then I guess you do some pairwise multiplication. Doesn't look that bad. This is x squared plus 7 and 8 is 15x. Let's see, that's 2856. Kind of nasty, doesn't it? X squared, let's see, plus 19x plus 90. Over here, what do you get? X squared minus 15x plus 56. And over here you get x squared, let's see, minus 19x plus 90. All right? Now granted, that's not a bad strategy. You could multiply this out now. What are you going to get? Let's put that down. This looks like it's going to be some work, doesn't it? And at this point, I'm starting to think if this was a question that was asked of me, I would say at this point, I'm probably thinking that maybe I'm barking up the wrong tree. But I do know something about this. If I do this, I do get x4. And on the other side, I get x4. Right, I get that. All right. Now I know they would cancel off, and then I'd be left off with a cubic polynomial here. Some cubic polynomial, some coefficient over here, some cubic polynomial over here. And by the way, what do I know about that? I know there's going to be 3 solutions to that. And again, I'm not wrong going that direction. I'm looking at that. Maybe I'll go a different direction. So I'm going to write this as x plus 7, x plus 10, and then x plus 8, and x plus 9. You may wonder why I'm doing that. It's because the internal terms are going to have some similarities to it. Like they're both going to be 17. All right? Let's not worry too much about that. On the bottom, I'm going to do the same thing. I'm going to say x minus 7, there's a dot there, x minus 10, and then I get x minus 8, x minus 9 equal to 1. And I'm going to do the same thing I did above. I multiply them out, but it's a different order of multiplication now. And I'll put those multiplications down for you. You get x squared plus 17x plus 70. And over here, you're going to get x squared plus 17x plus 72. One thing I noticed about those two guys there, they differ by 2. All right, that's pretty easy looking at that. And I see x squared plus 17x plus 70. The next one's going to be x squared plus 17x plus 70 plus 2. All right, let's do the bottom. What do you get there? X squared minus 17x now, and then plus 70. X squared minus 17x, and that's going to be plus 72 now. And they also differ by 2, and this equals 1. I can make a substitution now, and the substitution I'm going to make is I'm going to let A equal x squared plus 17x plus 70. And that means A plus 2 would equal x squared plus 17x plus 72. And then I'm going to say the bottom, I'm going to say b equals x squared minus 17x plus 70. And then I'm going to say b plus 2 is equal to x squared minus 17x plus 72. And I'm going to use this to simplify this. Let's put that down. So on top you get a plus 2, so equal to 1. On the bottom I get b plus 2. All right? Now this is easier for me to look at than the other problem, but I still need to solve for this. This looks like it might not be, let's take a look. What do you get? You get a squared plus 2a equals b squared plus 2b. What I do, I cleared the fraction. And then I'm going to solve this thing for 0 and try to use the 0 product rule. Now what do you get there? A plus b, a minus b. That's this guy factored. Well, let's factor this. I'm going to say plus 2, a minus b equals 0. I'm going to factor out a minus b. And what are you left off with? A plus b plus 2 equals 0. So what do I know looking at this thing? I know that a minus b is equal to 0. The other thing I know is I know that a plus b plus 2 is equal to 0. Well, I got to remind myself what a is. That's right up here. So a is x squared. Let me show what I'm doing over here. I can add these things together, right? Oh, not add, subtract, right? So x squared plus 17x plus 70. That's what a is. Minus the b. Again, we're doing this one now. Whoops. What's the b going to be? X squared minus 17x plus 70. Right. What do you do over here? Subtract. What do you get? X squared minus x squared is nothing. 17 minus 17 is 34x. 70 minus 70 is 0. Well, this looks pretty easy. X equals 0. We'll check that later, by the way. That's one solution, by the way. I'm expecting 3. I'm going to do this one now. And let's write that down now. What do you get? X squared plus 17x plus 70. Let's see, plus x squared minus 17x plus 70 plus 2 equals 0. This one looks more difficult to deal with. You get 2x squared. It's not so bad. These disappear, which is good news for me, by the way. You get 70 and 70. That's 140, 142. Let's see if I do there. X squared, 2x squared. The x's disappear, 70 and 70, 140. Yeah, 142. Divide both sides by 2. I get x squared plus 71 equals 0. I'm going to use the square root rule. I'm going to get minus 71. And x would equal plus or minus the square root of minus 71. X equals plus or minus I root 71. We found 3 answers. The 3 answers are I root 71, minus I root 71, and 0. As expected, 3 solutions. If you want, you can check them. I'm going to say the complex number looks like it's going to be a little work to check, by the way. But the 0 is pretty easy to check. I want to put out what I mean by that. You check it in the original. The original's over here. What do you get? 7, 8, 9, and 10. On bottom, what do you get? Minus 7, minus 8, minus 9, minus 10. I hope that's obviously equal to 1, by the way. But if you don't see that, do some reductions. Minus 1, minus 1, minus 1, minus 1. I'm doing pairwise because, 7 over minus 7 is minus 1, so forth and so on down the list. This gives you 1, that gives you 1. 1 times 1 is 1. It does work out nicely. Now, if you want to do complex numbers, you can. I'm going to say it's probably not worthwhile. But anyway, you can check them if you want. But this is the final answer, and we are done. Thank you.